You're listening to The Local Maximum, episode 229.
Time to expand your perspective. Welcome to The Local Maximum. Now, here's your host, Max Sklar.
Welcome, everyone. Welcome. You have reached another Local Maximum. It was good to have a week off last week as Aaron and I, we were at a little bachelor party. We took a party bus with some friends through the Appalachian area. We hit up, how many states did we hit up? West Virginia, Kentucky, Indiana, Tennessee, North Carolina. So it was a 5-state trip. Pretty cool. And I'm glad I had that Bayesian episode in the can. I hope you enjoyed last week's throwback episode where I was being interviewed on Bayesian inference. I actually enjoyed reviewing that stuff myself because sometimes I forget all of my background in Bayesian inference and Bayesian statistics that through all the projects that I've done over the years. And also that gives us enough background to get into today's interview, which is the author of a book that came out in the last few years on Bayesian statistics. It's called Bayesian Statistics, The Fun Way. And guess what? The conversation went the fun way. It went in all sorts of different directions, from philosophy of truth and logic. We mentioned some movies, political thinkers. We talked about functional programming. So if you are into learning things and intellectual discussions, you don't actually have to grasp the entire interview. We go all over the place. So there'll be some really strong, really cool nuggets of knowledge for you in there. And I think you're going to love it. This is the real deal for the Local Maximum audience. So without further delay, my next guest is an author and data scientist who writes the blog Count Bayesy and is also the author of Bayesian Statistics, The Fun Way. Will Kurt, you've reached the Local Maximum. Welcome to the show.
Oh, thanks for having me.
Yeah, it's great to finally be talking about Bayesian inference again. You know, this was a huge theme on the show starting from way back in episode 0. It was, hey, we're doing Bayesian inference. This is what happens when you're in a Local Maximum, all that stuff. So and some of my most popular episodes are on Bayesian theory, which is, if you can believe it, this is a popular subject.
I believe it, of course. I'm a little biased.
Yeah. Yeah. I'm sure you would. So I guess first is, I just want to know, like, what's your Bayesian origin story? When you learned probability and statistics originally, did you learn it from a Bayesian perspective? Did you learn it from a different perspective and then kind of have to move over after doing some research, doing some soul searching or whatever it was?
Yeah, it's a great question. So actually, I have a very non-traditional background. I don't know if it used to be a point people love chatting about, but so I'm actually an English major undergraduate. In undergrad, I prided myself on not taking any math classes. But my roommate was a mathematician, so he actually got me to see that math is in fact, a very, very interesting subject. It's actually really helpful because when you learn math in school, you kind of learn this computation first. I didn't really sort of see the deeper beauty of mathematics until my roommate kind of enlightened me, and it was great to sort of have that shortcut. So I actually ended up being very interested in math after that. I was a librarian, so I actually have a library degree. Still no math yet, started programming a little bit. So I actually eventually got a degree in computer science as well, but it took me a long time to actually get to math. So I largely am self-taught in a lot of mathematics, and that's why I came to Bayesian computation. So I was interested in data science. I had sort of a machine learning background. I was working at a startup at the time called Kissmetrics, and they needed me to run some A/B tests. And I didn't know much about the actual, I didn't know much about t-tests at the time or any of that stuff. And what I didn't like was I hated stats. I read a stats book. I'd done that before, sort of gotten sort of the basics. I think it was the head first statistics. But one thing I didn't like was running statistical tests and not knowing what it means. And this is prior to reading any Bayesian philosophy. So now I have a very strong opinion about that. But my intuition was I don't understand why I'm doing this. I don't really understand what this number means. And therefore I can't really use these tools out of the box because I don't feel comfortable, because I can't make a decision and say this is why. I can't just say this is the p-value and we're done. So I actually started working on in my head the idea of like how should you I'm doing A/B tests for websites, so you have two conversion rates, and I started thinking about how should I solve this problem. And I thought, okay, well, if this was a binomially distributed random variable and we had this many successes and failures, this would be the most likely. And then what happens if it was a different one, and iterate? And that's actually the beta distribution. That line of thinking gets you to the beta distribution, and basically you build out a Bayesian A/B test. And that got me reading. I was always to this day still filled with self-doubt whenever I do any kind of statistics project. So I was very, very anxious about my test design, and I thought I must have been doing something wrong. So that got me starting to read more and more books, and I realized that I was in fact a Bayesian, and that's really what excited me about that was my realization that there is this sort of rational approach to statistics. I always felt intuitively when I read classical statistics books, and I don't want to just say frequentist, I think it's a little unfair, sort of these sort of traditional, do stats to solve problems type books. I didn't really understand why things were happening, and I understood how to do the test, but not why. And then I realized there's this whole Bayesian world where, yes, we can just sort of take these logical things. And I'm a big fan of, in both code and in mathematics, building up things from first principles. So you really understand all the moving parts. And that way, if there's an issue, you can actually understand where that issue comes from. You can debug your thinking in that way.
So yeah, a few questions that come out of that. I mean, first, I just want to go back. So how did you go from being a librarian to then working at a tech startup as a machine learning engineer? Like that transition must have been tough.
It was a little bit of a long journey, actually. So it was a long process. I started a really interesting story. I don't want to go too deep into it, but I started. We can. I love telling the story, but I actually started out of undergrad, going to library school. I was working at the MIT libraries. I didn't expect that. Actually, my original plan was to work in public libraries, but I had done some accounting for a public library, and there was a team at MIT that needed someone that was good at sort of that type of thinking for acquisitions for books, and they hired me. So I didn't expect to be at one of the most prestigious institutes in the country or the world. I thought I was going to be at some small town public library. And being there, I got exposed to all of these really cool ways of thinking and thinking computationally. And I didn't know how to program yet. I kind of wanted to. And I ended up building these macros to automate my job away. That was one of my favorite stories is I sort of automated all the things I had to do. And I was talking to a friend and my manager came over and I told her, don't worry, I'm working. You can go look at my machine. It's running right now, all these things. Anyway, I took a Python class there, got into software, and then I started building all these tools for librarians in software. And then I went to work as a researcher. Once I got my degree, I went to work as a research engineer, a research librarian at BBN Technologies. They are now part of Raytheon, but they were the original ARPANET contractor. They were doing some very cool work in, this was before sort of the machine learning boom, 2006, 2008. And they were doing work with SVMs and all this machine learning. And coming from a library background, I was really fascinated by this because I saw the solutions to natural language processing problems they had involved the same concerns librarians had about, thinking about precision and recall and are you classifying these things correctly? But it was done in this formal way, which I really found attractive. At the time, I had no mathematical background. I was just learning to code. So this seemed like impossible, this world of doing that. So I ended up doing software engineering in libraries. I later moved to the University of Nevada, Reno, and I did software engineering as a librarian. So in libraries, you often have to have the degree in library science, very academic, right? You have to be a librarian to write code for libraries. So
Wait,
I have
so you're not still in Massachusetts, right?
No, so actually my journey through life has been, grew up in New Jersey mostly, moved to Massachusetts, moved to Reno, Nevada, moved back to Massachusetts, and now I'm back in New Jersey. So
okay, I was just asking because I would have been so like, oh my God, I should have had you in person if you were here because I'm here
no.
Salem,
I'm in New
New Hampshire.
Now, so I was actually just
right.
a few years ago, I was back in the Boston area.
Yeah. Although my co-host Aaron, who my listeners will know, he went to MIT, and so he would.
Great, yeah. It was a really cool place to work, and I really got exposed to so much. Actually, it's funny because I remember another thing that always sort of surprises me today is I remember, my job was to basically stamp books. It was kind of boring, but it was a cool place to do boring work. And I actually remember looking at all these machine learning and stats books and thinking to myself, would I ever be able to read such a book? And it's very funny to start writing those types of books now. So not only can I read them, but I'm actually writing books. So I've gone a long way. Anyway, so I was working as the title was application development librarian, but I was writing code for the library, building kinds of cool things. And then way back in 2010, so this is after the 2008 recession, those things hit academia at a different rate. So we started getting salary cuts, and I decided to leave into software. Software was great, but I got kind of bored quickly and realized I was really, really fascinated with this original insight that I was interested in sort of these quantitative approaches to understanding information. That, the library stuff got me thinking about data and information and knowledge and all this stuff, but I really felt like I was missing that. So I got a stats book, learned statistics, and then the Consumer Financial Protection Bureau was hiring a team of people from startups, and they were very open to me not being, the role was back-end engineer, but they were open to me being kind of a data scientist. So I went to there, and then from there I went to a startup. So that's how I got to this point in the story where I learned Bayesian statistics.
Yeah. No, there's a lot of really interesting stuff in there, and I'm sorry to pull on lots of different things.
But you can. That's why I said, the only reason I said it, I want to make it quick, is because there's a ton of rabbit holes you can go through. So I'm happy to dive down them though, if you'd like.
Well, there's one question that might open up new insights for me, because I don't know too much about what it's like working in a library or managing a library and all that. So do you think there were any insights you had from working in a library that helped you with software engineering and data science, in terms of organizing information and thinking about that?
I guess in a weird way, I think the one thing libraries don't have and library science doesn't have is, at least when I was there, there's a lot of sort of fear of quantitative methods. It's a lot of people that didn't, that went from history backgrounds or English major backgrounds into libraries. And that was something I felt lacking. I actually didn't like my cataloging class when I took that. I did terribly in that. And I didn't like it because it was a lot of rules without a lot of reason. And I think in a weird way, you are thinking about organizing information, and you're thinking about, actually, to pivot to the positive part real quick, the one thing that I really liked about library science, which I still use all the time, is one of the basic techniques you learn when answering reference questions when someone comes to the desk and asks to find something is you don't find them the thing they ask for. You clarify what they're looking for, right? And sort of, because oftentimes people say, I need a cookbook, and you say, why? What are you really trying to solve? And then you realize that their problem is actually different than the one they think, right? They're looking for specific. So that was a positive thing. But the negative thing about library science that I really was frustrated with, which I think helped me be more receptive to this sort of data science techniques, was the fact that there was this system of organization, but it was really it was based on a bunch of heuristics. There was no guiding principles. There was no information theory. There was none of that. And I thought, and so when I found it in data science, I think it resonated even more strongly with me. I wouldn't even say data science; I would say information theory, statistics. Data science I view as like the practical work-related aspect of these disciplines. So I think that's what made me excited, is when I saw that there is a way to think about knowledge and information in a quantitative way where you can really reason about these things.
So it sounds like it helped in a couple of ways. Like there were, like you said, the clarifying questions, which there were some takeaways, and then there were some. You had some reaction twos that you took away into data science, which is still pretty cool. It's still kind of neat to see that there's always the two different approaches. I had a comment about A/B tests. I don't know if it's going to turn into a question, but we worked I've worked on that with some people. We were doing some pretty advanced machine learning, but then we looked at A/B tests and after looking at it for a little bit, we eventually figured out what we should be doing, but it's a lot more complicated than you think. What, we're smart. Why can't we figure this out after a few, after it's not as obvious as you might expect. I almost sometimes my audience likes a little bit of a technical explanation. Do you think maybe we can, you could try an audio, which is really difficult to explain what the beta distribution is? Oh yeah.
You need to kind of have an intuition of what a binomial distribution is to start with. So the binomial distribution is just, if you have a coin that's 50% heads, 50% tails, you flip it 10 times, how likely is it to get 5 heads? How likely is it to get 3 heads? And blah, blah, blah. So if you think about this for a website traffic, right? If you get maybe 1,000 people visit and 100 click, you can sort of look at that as what's the probability. If you let's say you knew the conversion rate for the website, which you don't usually, right? Let's say you knew it's a 10% conversion rate, so you get 1,000 people come, 100 people click. there's a certain probability of that happening of all the even if it's 10%, doesn't mean you're going to get that expectation, right? You might get slightly less or slightly more. And then you can look at the probability of that. So the beta distribution is, okay, what if I looked at every possible binomial distribution that could have been behind this, right? And the example I was given, I'm sort of walking people through this, is that if you see a website that has 1,000 visitors and 100 clicks, what's your estimate for the conversion rate? You'd say 10%, but then you can always follow up and say, well, couldn't it be 11%? Couldn't it be 0.10001%? Of course, right?
Right.
So the beta distribution essentially is the distribution of all possible binomial distributions. And then you can, if you did that, they wouldn't be normalized into a probability, right? Because they don't add up to 1. They're all going to get sort of higher probabilities. So you just do some math and normalize it. And there's a couple catches and gotchas there. I think technically you really want to incorporate a prior probability distribution over that to make it exactly equal to that. But more or less, that's the idea. It's a distribution of how strongly we believe, given some observed rate of something happening, that we think that we believe in each of the possible conversion rates it could be.
All right. So I want to get in, and beta distribution is certainly covered in this book. I'll hold it up. Bayesian Statistics, the fun way, which it seems like it's around. This is not hidden in, like I was going around at Barnes & Noble. I saw it out. So congrats. I know it's probably came out a few years ago, 2019, which seems like a long time ago at this point.
Does,
but what did you, why did you decide to write this book? And did you try to take a specific approach to learning Bayesian stats that hasn't been done before?
Yeah. So I yes to all those. I think so. I actually was working on. I have another book out, Get Programming with Haskell. It's the first book I wrote, and I wrote that with Manning, and I was working on that when No Starch reached out. So I have the blog. I have Count Basie, which predates all of that. So the long.
So yeah, go. Let's start at the beginning. So you've got your blog, Count Bayesian,
and that blog actually started out of my anxiety. I talked about it. Sort of, am I doing this right? I was like, the best way, on the internet to learn something is to tell people how it works, and if it's wrong, people will tell you you're wrong pretty quickly. The funny thing I've gotten as a side to anyone who writes web content. I mean, you create web content. The biggest heuristic I've learned after all this time of publicly writing is that anytime someone comes screaming at you that you're a moron, they are actually almost always wrong. Like when you pause and look into the details, but anytime someone comes up to you and goes, excuse me, I've just been studying this for 30 years, but I think you might have that backwards. That person's always right. Like every time someone's humbly apologizing as they bring up something, and it's not like this bias. I actually, when I started, whenever people were mad, I always took it seriously and tried to really, because I thought I was wrong about everything. So I always try to double check things. And but my heuristic now is almost anytime someone comes screaming at me that I'm a moron, they're actually often not correct. But like I said, without fail, someone that quietly suggests maybe I don't quite have the perfect understanding. I'm usually fundamentally wrong in my assumptions and have to rewrite posts. It's only happened a few times in my writing career, but it has happened. And that's someone comes humbly to you, be prepared to listen. So but yeah, so I started the blog, and in part because I really wanted to put stuff out there and be told I was wrong. And I also was, I was an English major, so I finally I really liked writing, and I got into that. So I was writing the blog for a while, and it had, thankfully, really, my first post was on Bayes' theorem and with Legos, and it actually blew up right away. I didn't even have Google Analytics at the time, but I think it had like 100,000 views and got picked up by all kinds of, I think Flowing Data, or one of those old data sites. I'm not sure they're still around, but they picked it up and republished it. And it was just like, it was wild to have this thing you wrote in an evening published it the next day. It's all over the internet. It's on the front page of Hacker News. And so that was really cool. And I got really into writing for that, and just writing at an incredible pace. My earlier content I don't love as much in retrospect because of that. I was working with a lot of content marketers, so I was trying to like fuse techniques of content marketing with writing. I've changed my writing a lot over the years.
It's hard to experiment with especially different formats for the podcast. Similar problem.
And it's a tough thing when you create content, especially educational content. And it's something I think actually I'm very mindful of. And actually I haven't talked about a lot of these things, but there is this economic drive behind content creation where you can kind of fall in the trap where you want to either make a lot of money doing it or just get a lot of likes and ego from it. And the problem is inevitably that starts driving you towards like edutainment, right? Like you start you start missing on the real stuff. So I actually made a decision a long time ago. I'd rather be less successful and write about the things I want to write in the way I want. I'd rather write. There's actually a great Emma Goldman, the famous anarchist, has this great in her Anarchism and Other Essays. She has this great quote about how she stopped doing public speaking. Because she said when she would do these public rallies, everyone comes out and is cheering and is excited, and it's great. It feels great. This is written in the 1940s, I think, 1930s. This is not social media time, but totally relevant. And people would just be pumped. But she realized it would fizzle out, right? This energy would fizzle out as soon as the event was done, and no one cares anymore. And so she started writing because she said the 5 people, in fact, I'm quoting this, 70 years later as a testament to her correctness in this, right? The 5 people who will read and engage with your writing, that's much more valuable, right? Those few minds that will sit there and stew over it and think about it. That's the more valuable thing. So it's something people have asked me. I don't create a lot of video content. I do for my Patreon. I do for a small group of people, but I don't generally make video content, and I actually don't plan on it because I don't want to be pushed into that sphere. So that was a bit of a tangent, but it's actually something I think it's an interesting thing to talk about. I haven't really mentioned before.
We're doing video today, but that's a little different.
No, yeah, and it's not a total we can't do video, right? But there is this. It's something that's hard in content creation is you don't want to, and it's very tempting to be successful at all costs. But you have to ask what you want from your content. Some people do want to just be. They want to be a name on a billboard and be very famous. They want to be a household name. There's nothing wrong with that, right? I always use Kanye West as an example. I think Kanye West is misunderstood in some ways because he's someone that's constantly pursuing that next level of fame. And I think he's a great example of someone who you can tell is never satisfied with it either. But I can't blame him because everyone kind of wants that in their own way. There's a tendency in all of us to want to be loved by everyone and appreciated by everyone and very successful in everyone's eyes. But as a content creator, it's a choice you have to make where you want to go because it will change the nature of your content over time.
Absolutely.
So anyway, so I was writing a lot and getting a fair bit of attention. Was pretty happy with the blog, and then I years ago had done some writing on Haskell, and I had done some functional programming talks as JavaScript way a long time ago. And Manning reached out to me to do a review for actually I forget which book it is. I now think about it. I don't even know if the book is out. I don't know if
they've been a sponsor of us in the past too.
Oh yeah, Manning is great. I mean, Manning and No Starch are both excellent publishers. I really like working with them. They're also. I have nothing but good things to say about both of them.
Yeah. Wait, the other one is No Starch. That's this
No Starch. Yeah, No Starch is the publisher of the Bayesian book. And so Manning reached out to me for a review. I gave them a review, and they always, when you do reviews for publishers, they always ask, do you want to write a book? And I actually mentioned, it's really funny. I told them I want to write a book on Bayesian statistics. They did not have any interest in that, but they came back to me and they wanted to write a Haskell book. My first passion in computer science was programming languages. So I was really excited because I wasn't very quantitative yet. And I was really excited about programming languages. And I really was into Haskell and functional programming. And I kind of had actually given it up when I went to data science. I was kind of frustrated by how this pure programming paradigm was less successful than a few vectors in R. Putting a few lines of R, simple vector math, you can solve these really hard problems. That's so much cooler. Right. But I never really felt like I had mastered Haskell the way I wanted to. So I accepted the challenge, I guess, of writing a Haskell book. And wow, that was a hard thing to do. It was exhausting. It's a 600-page book. I can't believe I wrote a 600-page book on Haskell. It was a very interesting.
I can't even imagine the editing of that because I wrote an 11-page paper before and I just kept finding errors over and over.
Errors. I still get I get so many messages still from both the books. People will say, "Oh, great book, but page 137, there's a typo here." And I'm like, "Yes, I know. I had editors." Someone once criticized my blog. Actually, they're like, "This is not professional." I was like, "Well, I've got news for you. It's not a professional blog. It's just me." So I do this on my weekend between writing other books. So I don't get the perfect error correction on that. Editing is very tricky. And with that book, with the Haskell book, a lot of rewrites. There are the sections that I'm most proud of on monads, which is a tricky topic. I rewrote that whole 3-chapter section, I think 3 or 4 times until I was done. I completely rewrite. So a lot of work. And in the middle of that, No Starch reached out. And I've always loved No Starch as a publisher. And my dream was to one day write for them. They were they're sort of I really like Manning, but Manning always sort of writes books I feel that are kind of very practical and to the point, and they're excellent technical books. and I was happy to write a book for them. But No Starch, they're a very fun company, and they write a lot of these sort of like whimsical books, and they did Learn You a Haskell for Great Good, right? Which is sort of the
I've heard of that one. It's hard to forget that title.
Exactly, yeah, and that's a perfect example of the kind of book I which is funny. I never ended up writing a book like that. I was really inspired by that and books like The Little Schemer. I never wrote a book that was actually that wacky, even though I was really inspired by those people. But so No Starch was, I was always interested, and I really wanted to write a Bayesian book. Haskell was not my favorite thing. I just was happy to sort of solve this problem in my head of, can you write a Haskell book? Still can't believe I can. And it's actually enjoyed. Really, people that read it really like it. It's a much more niche topic, but the people there are actually, I get a lot of fan mail from that book with a disproportionate number of people reading it. So I'm
a huge fan of Haskell. I take a lot of inspiration from it. And one of my professors is an undergrad, the late Paul Hudak was one of the developers of it. Yeah. And so, that class changed the way I look at things. Yeah, absolutely.
Well, and it was a fascinating, and the reason I actually wrote that book, the big thing that motivated me was, I never read the Haskell book I really liked. And part of it was because everyone that writes Haskell books, except for me, is absolutely in love with Haskell. And I was not absolutely in love with Haskell. And I wanted to write a book from that perspective that says, yes, this is stupid and annoying, but it's also cool, right? Like, yes, these things are frustrating, but if you get past that, this is really valuable. And I felt that's what was missing from other Haskell books. And I was like, well, I actually quote in the preface to that, there's a great J.D. Salinger quote where he talks about, if you want to write a book, just imagine the book you want to read and then have the audacity to write it. And that's basically where that book came from. So No Starch reached out in the middle of that and said, you want to write a Bayesian statistics book? And I was like, I absolutely want to, and I want to write it with you. But I am like up to my eyeballs writing this Haskell book, so I'll do it. But it can't start until after this is done. They were totally understanding of that. And yes, and to your other question about what did I want something different, that was absolutely, I had a very strong vision with that book. And it's interesting the different motivations for writing. Like the Haskell book, I really wrote that as the Haskell book for me, and people liked reading it. I actually wrote Bayesian statistics for other people. So both methods of writing, I believe, work. But the thing I noticed with statistics books is they are all hard. and I think Krusky's book talks about that, right? Like you just need a lot of math. And they all assumed you knew statistics. And this frustrated me because my road to Bayesian stats was, this is the most rational logical solution to a problem I have. And so I felt the opposite. I felt like, no, this is what's hard is understanding where all these frequentist things come from and all these classical statistics. That's hard, right? Like, why do I have a p-value? What does that mean? Like, if you don't even know what your results mean, that's harder. And so I felt it was tough because I also kind of got tired of, I don't think there's any apologetics in Bayesian statistics the fun way. Almost all of their Bayesian books start with like an apology for Bayes and like, sort of, we know you know frequentist stats, here's why you should know this. And so the intended audience, this is changing now. It's changed even since I've written this book a bit. There's a lot more things in that space, but most Bayesian books started with explaining, okay, you already know frequentist stats, here's why you should bother with this book. And I wanted a book. Someone once asked me something about the title of it, and I actually really wanted in my heart to be able to just call it Statistics the Fun Way, because I want Bayesian statistics to be the statistics people do. I want that to be how people think. I don't want to clarify it's Bayesian.
Make it a little bit of a Trojan horse. Maybe that's not a good...
Exactly. And also I felt like, there is a marketing side of these things. The truth is Bayesian is a selling term. And also it is clarifying. I didn't want someone that has my biggest concern actually is someone that has a stats class that's frustrated will get that book and then still fail stats because they learned something, but it doesn't match what's on the exam. So one day I want to live in a world where it doesn't have to be called Bayesian statistics the fun way. It can just be called statistics the fun way. But yeah, so that's what I wanted. I wanted to create a book for a really broad audience of people. I think I mentioned it, the kind of thing I would like a CEO of a startup to be able to read on an airplane if they have to. You can read it pretty quickly and get the idea. And it's in part because I feel like a huge part of Bayesian statistics is a way of thinking and understanding problems. And whether you're a marketer or a business person or an academic or just someone that likes to think about stuff, there's a lot of value in Bayesian statistics and Bayesian thinking. And I wanted to write a book for all those people. And it seems like it's worked. So I'm happy with that.
Yeah. So to follow up on that, like what kind of feedback have you gotten? Were you happy with were there types of people who picked up the book you weren't expecting? Or,
I mean, I'm always surprised. I guess I shouldn't be. I kind of live in my own little bubble. I'm always surprised how big the topic is in academia and how most of my audience is academics. I always do kind of write for myself, and I'm not by nature an academic. I've done tons of schooling, so I mean, it's not like I don't have academic experience, and I know it was faculty at one point when I was a librarian. But like, I don't think of academics as my primary audience, but they're a pretty big audience for it. But I've seen all kinds of people, and the reception has been honestly what I would expect. People often ask, like, what would you change about it? And I don't think there's anything I would add or take away from the book. I think it's good, and it's been, for a stats book, very successful. It's kind of surreal to actually. I think if you just search Bayesian Statistics on Amazon, it's the #1 book, and it's got, I think, the highest number of reviews. Understandably, it's not, because it's more general, right? So by definition, more general books have more audiences, so it's going to sell better than more specific books. But it's still wild to see that. And I think I just checked today, and it's typically in the top 25% of all statistics books, top 25, not percent, top 25 of all of Amazon's statistics books, which is another, like, wow, that's a wild thing. And like you said, you can buy it at Barnes and Noble and things like that. So it's actually, it's probably been more successful than I even thought it would be. I didn't realize there was that much a demand. And it's cool to see that, because it's a world I want to live in. I want to live in a world where people are more Bayesian and think this way. So it's nice to see that, yes, there are actually a lot of people getting into it.
Do you think that Bayesian inference should be taught in school or introduced in school at like a younger age? Do you think this could be taught?
Boy, I was thinking about that question. I saw you post that, and all I could think about is like,
and also like, what level is this book? I'm getting too old to.
I'll answer the level of the book first, and then get into
But I sort of thought, maybe I can get this when I was in high school. I'm pretty sure.
So the idea, so I do in the preface, I think I say, or somewhere that I mentioned it, the only requirement is a vague memory of high school algebra. Okay. That was the intention of it. I also have that problem as you get older, you forget what people know. And what you don't. And even high school algebra is very, very fuzzy for a lot of people. Yeah, so that was my intended math audience for that book. And at the same time, as you've noticed, if you read it, you talk about integration. I don't think we talk about derivatives too much. They don't come up, but it's mentioned in the back of the book.
Yeah, but it's not like it's not like throughout the whole thing. Like, oh my God, if I don't know integration, I'm going to be. It's but like, at the same time,
I didn't want to avoid those ideas. That was a choice of mine, actually, because one thing I actually wanted that book to do, which I think it has done, is I wanted it to be an introduction to mathematical reasoning as well. I didn't want to. A lot of these intro books will completely like they're ashamed of mathematics. They won't talk about it. They think calculus is the devil and you can't talk about it. And I didn't want to go that way, because I actually deeply believe that the mathematical reasoning behind it all is helpful. And it can be too much. And if you open your standard textbook with math, it gives you a headache and it's too much. But once you can pull it apart, there's a lot of insights in the math, in the notation, into thinking in these mathematical terms. And so I didn't want to shy away from math, and I didn't want to advertise, there's no math. I actually wanted the reader to realize that the math isn't tons, but you shouldn't be afraid of it. And the math that's annoying, integration is a perfect example of this, right? Doing integrals is the computation part, to me, is still very annoying and tedious, and I don't like it. But we have computers to do that. So the concept of integral is hugely important. You should be aware of that. You should understand what area under the curve means, and it's an important thing. And the problem is, for most of the history of sort of teaching these topics, understandably, because we didn't have computational tools, they're intertwined, right? Learning what a derivative means intuitively, understanding it as a tool, and understanding integration and integral calculus as a tool involved the computation to solve those. The computation is tedious and, in my opinion, kind of boring. And not something I want to do, and error prone, but the ideas are fundamental. You really have to understand them. And once you do, a lot of these things become much easier to reason about. And getting less scared. A huge inspiration for this book was actually the great Calculus Made Easy, which was written in 1908. And he just talks about, I forget his name, Sylvanus Thompson or something like that, but he talks about, the integral sign is just a big S, and it means sum of, and the dx means little things, and it's just the sum of a bunch of little things. And you go, oh, wow, what a clear explanation. And so I feel like people have this sort of math phobia because they see these symbols. I still have it. I still have this reaction when I see textbook math of, I'm an idiot, I don't know what this means. And then all I have to do is say, stop. No, it's just dense. Read it. Take your time. And I get it. And so I wanted to help people without even thinking that's what they were doing, start getting familiar with mathematical notation. And I think I achieved that too, because I really like it because in the Amazon reviews, I don't read them too often, but I do check them occasionally. There's one person that says, I hate this book, it's not technical enough. And another person that says, I hate this book, it's too technical, which means I've achieved harmony. I must have hit the sweet spot because people are complaining both directions. So.
Right. It's one of those things where, like, you know, you have to, I've had feedback like that too, where it was like some people said it was too advanced and some people said it was not advanced enough. And it's like, well, what do you expect me to do? Yeah. I don't know. It's like, you can't always choose your audience. So,
yeah.
Oh, so going back, like, what do you think should be the educational strategy for this? Obviously, we don't have to remake the whole math curriculum here on the show because there's a lot we don't know. But like, do you have any thoughts on like how could this be introduced in high school or even earlier? Like, you know, is there a conceptual part of it that?
When I saw you posted this question on the list, my first thought is like, wow, our high schools our school system is in such a disarray right now. It's sort of like asking if we should change the wallpaper in a burning building, right? Like, yes, but I feel like we have so many dire. Like, we're not in that world where that's actually our number one educational concern. Like, because it comes up the frequent variation on this I hear is, should we teach calculus in high school or should we teach statistics? And this is like, there's a lot of people that have seen this sort of meme in the past of like, oh, we should throw out calculus and teach statistics, which is silly to me.
Well, there's overlap. So
yeah, because you can't have one without the other. And so there's really two parts. Like, in the realist part of me is like, well, we're so far from that being what we're worried about. Like, let's stop getting kids murdered in schools. Let's, like, teen suicide rates are through the roof right now. It's been escalating every year. And so, you know, I always, whenever these topics come up, I always like to bring them up because it's sort of one thing I can't stand about the statistics world is there's often this tendency to, like, in technical fields in general, sort of put your head in the sand and talk about technical topics and not engage in the fact that there are real things happening in the world that are much bigger priority before we worry about whether it's calculus or stats at the end of 12th grade. I think students right now aren't in an environment where if you read this book in high school, you have so many other things in your head. This is not going to impact your worldview. You're not going to go, oh, geez, you know, if there's a shooter in my school because of Bayes' theorem, I should, you know, it's not like where your reasoning is. So, like, you know, in the abstract sense, I think it's like you can't throw out calculus for that question. The calculus versus Bayesian stats. Don't throw out calculus in favor of statistics because they're this together. But it's such the wrong problem to think about. Big picture, yes, everyone could benefit from Bayesian statistics. Everyone should learn some Bayesian statistics. But and this is actually where I really bring it up because Bayesian statistics is an epistemology, right? It's a way of understanding the world. So if you ignore the world in favor of talking about just statistics, you aren't really talking about it. You're doing both fields a disservice, right? So I think it's a tricky question. Yes, in general, everyone should learn both. It would be great. I think it's an important life skill. And to get a little bit away from sort of the dark narrative there, I've long felt since I was an English major, you know, in English, I used to have this thing I used to say all the time that Foucault and Bayesian statistics were equally important in informing my worldview. And I think that's actually an important thing. There's people that don't learn stats, and I think that that's very dangerous because we live in a world where statistics are used all the time to convince you of things. And it's incredibly important, as at least in the adult world. So we can ignore the sort of the educational system and think, as an adult, what skills should we have? And the reason why statistics is very important is because you need to, you know, all these claims that people will say, like, you know, eating this thing causes cancer increase or whatever.
You have charts going by on social media all the time, and almost all of them are make me mad.
Exactly. And most of the time, people don't understand how the even educated, quantitative people don't realize how a lot of these social claims, this comes up around relevant topics. This is actually related to gun control issues, right? Because the one thing I find fascinating about all these topics is if you actually look at the data, it is complicated. And so this is like sort of my, in fact, years ago, I used to do data science mentoring, and people were always looking for projects. They had these huge ambitious ideas. I said, take a point you care about and list down all of your assumptions you have, and then go get data to support them. And I promise you, one of them will surprise you. And I actually forget the details, but I used to use gun control as an example because I grew up in the Northeast, relatively liberal world, so you can kind of assume my default views on gun control. But truth is, you look at the numbers, and there is a lot more complexity than you think, which does get to this point where this is where I think statistics and understanding these modeling principles is important, because a lot of how you're told the world is it assumes sort of statistical things. And once you realize it's almost all regression models, right? Every little fact you get, it means that someone put this data in a regression model and saw a p-value that was low enough on a coefficient, and then wrote an article saying X causes Y. And once you see that, you kind of realize how much more skeptical you should be. And the flip side is, it's like I said, with this project for these data science, these mentees, is that it was true. I had some really great students interested in a lot of really cool topics about diversity, and without fail, all their assumptions, there would be one that surprised them when they actually tried to put the data together to demonstrate that. And I always say the flip side of that is, if I'm wrong, then you've quantitatively proven your place, right? Your position is now backed entirely by data, and you can really be confident in your views. But I said, my experience has been, you always do find one point where you say, oh, I didn't realize that. Like I didn't know that was happening.
Yeah. So you've written about using kind of a Bayesian way of thinking in order to analyze the news. Maybe can you give us like an example of how that helps?
Yeah. So that article, I was really happy with that. So it actually came to me. So I think for context, this is important. It was actually right before the war in Ukraine broke out. So it was brewing. So it was a lot of news reading, and I have like Apple News on my phone. So I'll read the news, and I realized I had this habit of sort of skeptically reading the news and sort of trying to figure out what's actually being communicated, because the news is hilarious. Like there's all kinds of strange things. So I think the article I talked about there was one about migration patterns around the state and around the country, and it was about the basic narrative they were trying to imply is that people are fleeing from different parts of the country to other parts based on political affiliation, and we're going to build these clusters of unified political beliefs. And I think implied in that was sort of feeding into this kind of narrative we have in this country about a lot of anxiety of sort of like, I don't want to say anxiety about civil war, but this sort of really strong division in the country. And so we have all that built up in us, right? So that's your prior, right? So if you think about where you're going into the article in Bayesian terms, your prior is all this information you're bringing to the table, right? And your current feelings. So the article was trying to claim that. And so I thought, this is actually, you can apply Bayesian thinking to this. And this is actually where I think Bayesian thinking is super valuable, and kind of cleaning your head and keeping your thoughts clear. And so you can say, here's my prior information. I'm going to this article. I actually think it's right. I'm reading a lot of this stuff. I'm feeling a lot of anxiety. I think that it's probably true that we're getting these huge clusters of Trump supporting populations and then people fleeing. But when you actually read the article, they had very few data points to back this up. And then the ones they had weren't super convincing. So the one I remember off the top of my head was that there was this sort of like migration from, well, first off, they had these sort of contradictory claims, like, oh, people are moving from Florida to Texas. And like, well, Florida and Texas are both fairly, like, it doesn't make sense with that narrative. But the other one was California. And California is also a complicated state because it's got a lot of diverse political views, actually.
Right.
And but the thing that was funny is that the rate of migration from California to Texas was exactly proportional to the population distribution of, like, a lot of people live in California. So yes, a lot of people from California move to Texas because there's a lot of people in California.
Right.
And it's sort of like your likelihood, right? Like, here's this argument they're making. What's the likelihood? What's the data? And then what's your conclusion? And I think it's actually a really important part of this. I realized when I was writing this article is that oftentimes when we read the news, we come up with this weird binary outcome in the end, like that's BS or that's real, and I'm freaked out. But the real conclusion isn't that this isn't happening, right? Like, the conclusion of the article is when you take your prior of this is happening, you look at this argument and go, well, it's actually not very convincing. If anything, it kind of dissuades me from thinking this is real, because what I would expect under a normal migration pattern would be a proportional migration from the population size. That's what I would expect, right? And I dive into a little bit more.
So the data wasn't as convincing as,
in fact, the likelihood in this case, which is the data there, right? Like the data given the hypothesis, this actually, to me, have felt like this is what I would expect if there wasn't systemic, politically motivated migrations. I would have expected either California to be much larger or whatever, and I'm not convinced by this. And so the point in the end of the article too is that you shouldn't leave saying, "Ha, that article's BS. I don't believe this." You should think about it in Bayesian terms. And what you have is you have a weak prior belief that this is true. The actual likelihood, as explained by the article, And also, when you think about terms of trying to data and your hypothesis, you also ignore a lot of the nonsense. Most articles are filler and trying to send this ominous feeling. When you just look at what are the claims they're actually making to back this up, you reduce much of the reading. But the end result is, isn't this isn't real because this isn't supporting that. It's okay. Now I've taken a slight this isn't real combined with a slight this is real, and I leave kind of going, I don't know. I need to see something more convincing. The next article I read in this topic, I'm actually going to be slightly less convinced going in, but I'm not saying this is complete BS, right? I'm just saying that I need some more stronger evidence, and so and that is sort of how we should read these news pieces. The tricky thing, and this is actually why I wrote this at the time, is because I could feel this sort of Ukraine situation boiling up, is it is tricky when you get into an environment where you can't trust data anymore, right? So as soon as military conflict breaks out, we're kind of in this this sort of propaganda space. But even ignoring that, a sort of more neutral example is COVID right now, right? So with COVID, we don't have data, right? Like the biggest thing is that current testing is way behind, and the numbers don't reflect what's actually happening pandemic-wise. And there's been a bunch of articles describing this. And this gets to like my Foucault part of the Bayesian statistics point from earlier, right? Like you need to know Foucault, you need to understand how power works, how the world works, and you need to understand the stats. So to read an article and not get overly, hit by the sort of ideological driving of the article, you need a sort of data-based approach. But the flip side is we take data as kind of a luxury, especially in the data science world, in the math world. We've lived in a great time where there's this tons of publicly available data. The government produces data on everything about CO2 in the atmosphere is available to us. All these things are available to us. And we can most of the time trust it. But where happens to your Bayesian tools with COVID data right now, right? It's really hard to paint a clear picture if your testing isn't there, right? How big is the pandemic right now, really? How concerned should I be, really? If the data isn't there, it's very hard to figure that out.
Yeah, absolutely. There's so many things to pull on, and I don't want to, we only have so much time. I'm like, I'm sort of thinking like, okay, who's Foucault? And that's going to probably take a little bit too long. I did have, maybe we'll have to bring it up on another episode. I did have one more question that, again, this has been a whole episode on the local maximum. So maybe you could just get your takeaways, but this is the kind of last, and then hopefully it's okay if we go a little over.
Oh, sure.
But like we talk about priors a lot in Bayesian inference, and I've spoken about how to come up with priors, and it's always like, oh, well, I'm hand waving a lot. There's no like simple answer. It's always like a lot of, here are some ideas that you could use to come up with priors. What strategies do you like best when explaining how you came up with priors? Do you ever get pushback on the idea of having to choose a prior?
Yeah, it's a great question, and it's something people are very concerned with in general as Bayesian stats. And I've actually always find it's a bit overplayed as far as the concerns with it, because there's a couple of cases that happen in real life, especially in a big data. So in a big data world, you almost always have millions of observations, so it doesn't matter, right? Like you have so many. I've been building some statistical tools at work for use cases where people will send campaigns out to hundreds of thousands of people, and I actually realized you don't even need statistics because the confidence around the things you're predicting is so tight. It doesn't even matter anymore, right? Because at that volume, you don't need statistics. Okay, so that's the one case we don't have to worry about priors at all, because you can choose them or not. It's not going to matter. The second case,
unless you choose a Dirac prior, where you're
exactly. Yeah, you can find some way to get kind of weird results, but like but the second case is, for a lot of data in this world, we actually do have a lot of prior information. And we can learn that. So, with A/B testing, again, if you want to incorporate priors in your A/B tests, it's not that hard. You probably have run tons of marketing campaigns before. You can build a distribution over that and actually have a prior probability pretty easily for those. And so those are fairly common. And then we get left with this sort of like my soft priors, right? And how should I be? And this is usually being used for more casual inference anyway, or limited data where you're kind of in this environment where you have to make a choice. There's a couple of parts to this. One is just go with your gut, because that's what you're trying to model anyway, right? Like in this case, we have no data to back, and you just sort of have your own personal feeling. You have to sort of quantify your gut and do the prior predictive check as it is. And does that make sense, right? Like for example, with websites, I've done website A/B testing forever. When I don't have data, I forget what prior I pick off the top of my head, but I'll just plot very weak beta distribution priors until it looks kind of like what I feel is reasonable. It shouldn't have a lot of things over 30% conversion, because nothing has over 30% conversion. Open rates maybe, but you can kind of get a feel for it. But the other part of that is when you're using these kind of squishy priors, the real question is how sensitive is your conclusion to different priors, right? So you can often find that you can have multiple degrees of sort of extreme beliefs, and that doesn't really change your conclusion based on the data you have. Or you might be able to find that if you have very, you might find there's a case where two very different priors lead to very different conclusions. But that means, like, that's where I like Bayesian reasoning. That actually is a good thing. If it's very sensitive to, if you have a coworker who disagrees with you radically, and it means that the conclusion of the Bayesian analysis is you should do totally different things, then that means you actually have to get more data, right? The conclusion from that is we do not have enough data to make a decision. And if you still have to make a decision, then it just goes back to the old world of you two have to argue about whose prior is better, right?
Right. But I think it actually helps, because the fact that you have a prior is that you're each quantifying with numbers and with functions in terms of what your initial beliefs are. And so you kind of show, oh, this is my picture, this is your picture. And so we at least understand what the difference of opinion is. Whereas if we didn't have priors, and we were still arguing, we wouldn't even understand why we were arguing. Yeah.
And it's true. And it's also, it's sort of this is the English major part of me, is I kind of hate this sort of myth of the universal truth, right? I'm a big, there is no universal truth. There's no point of objective view anyway, right? So I think that's sort of the classic, like, this is subjective. I don't have a lot of patience for it, because in the cases where that subjectivity matters, right? Like, that's, you can't just wash it away by saying we're going to ignore it and choose a uniform prior. I mean, A/B testing is a perfect example of this. Conversion rates are not weakly uniformly distributed. I know for certain that your click-through rate is not going to be 100. If it is, something is wrong, right? It's not going to be 100%. It can't be. It can't be 90%. If that's happening, something is wrong, right? And so there's no way that's it, right?
As someone who used to measure ad effectiveness,
exactly. But that's exactly the point.
That would happen sometimes.
So pretending it's not an issue is not great. No, and so I agree, and that's sort of my my strong belief. Actually, the flip side of that is I do think. I think it's not really that controversial of an opinion in my grand scheme of controversial opinions, but there's a lot of love of sort of hierarchical modeling in the Bayesian community today. And I'm actually a little skeptical of the overuse of that, because hierarchical modeling, for those who aren't familiar, is you basically assume that you have a bunch of observations of something you're estimating, and you assume that population itself comes from some prior, and you learn that prior distribution and use that to make better, tighter predictions. But the catch there. So
I did an episode in that a couple of years ago with Alex and Dora, the Learn Bayesian Statistics podcast, and he does that for. You've heard of that?
Yeah, I've been on that podcast.
You've been on it. Fantastic. Okay, great. So he does it for election modeling, which sounds very reasonable to me.
Oh yeah, and it is reasonable in a lot of cases, and it can be useful for two ways, right? One, it gets you tighter estimates because you're assuming these things are similar. The other thing is you get this prior you can look at, so you can actually learn stuff there. That's sort of that hyper prior or whatever that you've learned can tell you something about an unobserved variable. So it's not to say that it's not useful, but there is this sort of like, I think it's because people like complexity, because it makes people feel like they're doing something very smart. There's a lot of people I find that
I know the feeling.
Yeah, right. But I think it's dangerous, because I think people forget that it's a big assumption to say things are alike, right? You're actually building, the whole point of Bayesian stuff is that we're not making all these wild assumptions in our models. And you start saying, I assume all these things are similar because it gives me tighter bounds. That's actually a pretty big assumption. And another example of this is, which is similar, is quote unquote robust regression. I think I probably complained about this in Alex's podcast too, but I hate the name robust regression, because it should be called, so if you're not familiar with that, it's you assume a student's t-distribution, sort of a longer tail distribution rather than the normal, which means that you're less sensitive to outliers. which I don't believe in outliers Bayesianly. I mean, they exist in a sense, but what is an outlier, right? You're already assuming a model in your head if you say this is an outlier, right? If you're surprised by the data, you should be surprised by it. And that's a good thing. When you're shocked by a number, and if you have an explanation for it, you know that the machine broke when you're measuring things, so we should throw these out. That's fine. But a robust regression will actually ignore data that might actually be meaningful. Sometimes things being 7 sigma away from the mean means something, right? Yes, it will break under a normal assumption, but sometimes them all should break. I've actually had a case where I was doing modeling, and for a company I was working with, and one of the things we were doing involved I don't know how much I can give away, but it's sort of changing the sort order of things, changing the behavior of things, and trying to gauge how their performance changed. And I had some exploding coefficients with a regular generalized linear model, and I thought, we should, because they weren't, this item wasn't selling, and I thought, this is a great example of when we should use a hierarchical model, because I can learn the distribution all these products convert, and I can bound it. But it turns out there was actually a bug in the code, and it was doing something wrong in what we were doing. And if I had used hierarchical models here, I wouldn't have caught that, right? If the coefficients weren't exploding, I wouldn't have noticed something was wrong. I just would have swept it away. So it's a great tool when you're like baseball player is a classic example, right? Baseball batting averages. We all know they're people. We all know they're roughly the same. They're playing the same sport in the same conditions. Yes, you should use a hierarchical model. Election stuff can be also useful because in elections, you're kind of modeling. You're not so much concerned about getting those things, I assume, about getting these tighter estimates. You actually want to know what's that latent distribution this is coming from, right? That's right. So there are plenty of cases where it's the right tool for the right job. But I think because it's sort of the thing you can do with Bayesian statistics, you can't do as easily with frequentists. There's sort of a tendency to really want to do it a lot. And I think it's a big decision to make, to choose to assume everything is the same, and it's a big thing to bake into your modeling assumptions. So prior,
I'm always surprised by how far you can get with a simple model sometimes.
Oh yeah.
Even though I'm like, well, I learned all this. Why I want to go more further.
Well, and it also depends on the use. One thing I always point out with linear models, it's funny because my real life work is always in sort of data science teams, and there's always a lot of people that have machine learning backgrounds, and I'm always pushing for my current team is great actually understanding this, but other places I've been, people are like, we got to use nonlinear models. The world's nonlinear, and I'm like, well, first off, most things in practice, first of all, you're modeling expectation almost all the time, right? So these normal assumptions are actually not such a bad thing because expectation is Gaussian, right? Central limit theorem tells us that. But the other part of it is, in a practical sense, I don't even know how to make nonlinear decisions as a person, right? So yes, if you're having an algorithm make all the choices, it's okay to be nonlinear. But if you're doing any kind of analysis where people have to use this to make an informed decision, you don't really think in like squared terms even, right? Like you think in very like, do I push the gas and the car goes faster? Yes or no, right? Like you don't think about the actual curve as the car accelerates and you push the gas. Same with the brake, right? Like when you make decisions, you're making very simple linear decisions. So any kind of analysis that ends up in a decision-making context for humans to decide, especially a committee of humans, you really need to. People make yes/no decisions. They don't even make continuous variable decisions, right? Sometimes, like gas pedal, you do, right? You push a gas pedal in the car, you do think harder or softer, right? But your brain is still thinking kind of linear, right? I push it much harder, I'll go much faster.
Even then, there's probably only a few different modes. It's not
exactly. Your foot has sort of like these sort of discrete places you probably end up, and
maybe 10 of them.
So, but that's the thing I actually almost never see people talk about when they talk about linear models. They'll talk about like, approximations and the validity of an assumption about, like, is a linear a good approximation? That stuff's all important. But if your tool is to bring a decision to a team to make, right? Should we advertise on Sundays, or should we increase the cost of this ticket or something? Those things are linear things that at best have a continuous component, but usually it's just a binary thing. Like, we'll stop doing this. We won't open at night, right? Like, those type of decisions, all of them are linear. And if your model is not linear, then you can't make those type of decisions, right? So, so it depends. And like I said, this is where there's like, if you're Google, right, and you are like, yes, we're going to automate a bajillion decisions all the way to the end part. Yes, then nonlinear systems work really well for that, right? It makes sense that you have a very complicated nonlinear function you're learning that's going to be making decisions all the way to the end. But any kind of analytics focused stuff where your humans are going to ultimately be consuming it. Why is churn going too high? What can we do about sales? Those things always are linear decisions anyway.
Interesting. That's I never heard it put like that. I think I want to think more about the linearity of decision making, because I'm always looking for more topics.
Yeah, and I actually don't have a good theoretical text. This is sort of personal experience. So I'm waiting.
No.
Someone will email you and be like, "Will is
but...
totally wrong." He's an idiot.
No.
Read this book.
A lot of times for this show, I take a topic and then I do a little bit of thinking about it, and then I do a show, whether it could be a solo show or one with my co-host. So it's always good to have some ideas in the back pocket. So thanks for coming on. Thanks for taking all the extra time.
Oh, no problem.
Will, I just do you have any last thoughts, and where can people find your stuff online?
Oh, geez. Okay, so people can find my blog is Count Basie. It's a pun on the jazz musician. And then I do have a small Patreon that I mostly do it as a way to have a sort of community of people I can just chat with. So those are probably the two best places to find me. I am on Twitter, though I use Twitter less these days. So if you reach out to me on Twitter, I will eventually get in touch with you, but may not be that fast. I think that's sort of the basics. I am working very slowly on a new book with no starch. It's called Tentatively Hacking Statistics and with Python. And it's all about, the second half, which I haven't even written yet, is all about differentiable programming and sort of building up statistics from scratch. The theme of the book is building up statistics from scratch and all these cool tools. So it's should be an interesting book, but it's a crazy time, so it's taking its time to get written.
Yeah. Well, if you want to do a book tour, a podcast book tour after you put that out, you're welcome to come back on the show. The book is called Bayesian Statistics: The Fun Way. Will, Kurt, thanks for coming on the show.
Thanks so much, Max. I appreciate it.
All right. Just want to remind you to remember to join our locals, maximum.locals.com, to support the show, and also to talk to people, talk to me and Aaron and the people who, other people who listen to the show. It's a lot of fun on there. So, next week, I think, might have Aaron on for an update. I might do a solo show. I'm not sure. But I think I'm going to do an interview related to design that's coming out soon. I haven't done that in a while. That's exciting. Have a great week, everyone. That's the show. To support the local Maximum, sign up for exclusive content and our online community at maximum.locals.com. The local Maximum is available wherever podcasts are found. If you want to keep up, remember to subscribe on your podcast app. Also, check out the website with show notes and additional materials at localmaxradio.com. If you want to contact me, the host, send an email to localmaxradio@gmail.com. Have a great week.
Feel the power.